Okay, so when we want to talk about the acidity of tertiary butanol and ethanol, look at these pKa's. And we're going to find we have a little bit of a problem here, okay? Look at these pKa's. So if we have a pKa of 18 and a pKa of 16, you'd say to yourself, how could this be possible? The, the induction alone would not be enough to explain that, right? So typically you see one is 100 times stronger than the other. Which is the one that's 100 times stronger than the other? Say it out loud to yourself. Which is the acid that's 100 times stronger? It's ethanol, right? Ethanol is 100 times stronger than tertiary butanol. And we can't explain that because of the atom. See, the atoms are the same. Atoms are the same. There's the atom, right? Resonance, there's no resonance. Induction, that's the closest thing to it. But the orbitals are identical, right? And so we can say something about induction, but that's not enough to appreciate that it's 100 times stronger of an acid. Ethanol is. Wow. Okay? So why is that? Well, the difference in acidity is due to the relative stability of the conjugate bases, as with all acids, okay? So the ability of the solvent to stabilize conjugate bases comes into play for this example. And so we're going to call it solvating effects, okay? Solvating effects explain this. Watch this. If we have the conjugate base of tert butoxide, right? This is a minus here, okay? So there's the conjugate base of tert butoxide, and here's the conjugate base of ethoxide this conjugate base, I'm sorry, of tert butanol, okay? And here's the conjugate base of ethanol, right? So look at what we have here. It turns out that it's difficult for the solvent molecules to actually get to that oxygen, that negative charge there, to resolve it or to dissolve it, okay? So it turns out the solvent, which is stabilizing the conjugate base by charge-charge interactions, you can't get as many solvent molecules in there for the tert butoxide as you can for the ethoxide. The ethoxide is a term that we're going to use many times this semester, sterically hindered, okay? And so since it's sterically hindered, that means it's difficult for the solvent molecules to get in there. All right, so this is an effect that we're going to call solvating effects, and it has to do, again, with the stabilization of the conjugate base, this time by solvents.